In this video, we are going to learn something about composite functions. Composite functions. That is differentiation of composite functions. This is one of the major or main chapter in differentiation, because when the functions are given, either they will be in the standard form or they will be in the composite form. If you know how to differentiate composite functions and if you know the standard forms, you can solve sums based on any further chapters. So composite functions, you should make it very perfect. Before defining what is composite function, first I will give you some of the examples. So with the help of examples, it will be very easy to identify, or it becomes very easy to find out what is difference between standard functions and composite functions. So I will write some of the functions here. So like y is equal to sine 2x, y equals to sine square x, y equals to sine square 2x, y equals to sine inverse of 2x, y equals to e raised to 2x, y equals to a raised to 2x, y equals to a raised to minus x, y equals to log of ax, y equals to 2x plus 3 whole raised to 5, y equals to 1 upon 2x plus 3 whole raised to 3, y equals to sine of cos x, y equals to sec of tan inverse of root x, or sec of tan of root x, y equals to sine of x square plus 5, y equals to cos of root x, y equals to root of sine of root x, y equals to root of x square plus 5. Now we will come to these functions one by one. So with the help of these examples, we can differentiate exactly between standard functions and composite functions. So first one, I have taken sine 2x. We know what is derivative of sine x, but we don't know what is derivative of sine 2x. So this doesn't fit in our standard form. Now if I go to second one, y is equal to sine square x. We know what is derivative of sine x, but we don't know what is derivative of sine square x. Similarly, third one, sine square 2x. We know only derivative of sine x, but we don't know what is derivative of sine square 2x. Next one, sine inverse of 2x. We know what is derivative of sine inverse of x, but we don't know what is derivative of sine inverse of 2x. This is not in standard form. Next, e raised to 2x. If it is e raised to x, we know derivative of e raised to x is e raised to x. But here it is e raised to 2x. We don't know what is e raised to 2x derivative. Then we come to a raised to 2x. if it is a raised to x, we can write a raised to x into log a. But instead of a raised to x, it is a raised to 2x. Next is a raised to minus x. If it is a raised to x, we know a raised to x into log a. But here it is a raised to minus x. Next one is log of ax. If it is log x to the base e, we know what is derivative of log x. Log x derivative is 1 by x. But here it is log of ax. 2x plus 3 whole raised to 5. If it is only 2x plus 3, we can write derivative of 2x plus 3 using u plus v formula. But here it is 2x plus 3 whole raised to 5. So we cannot apply any standard form here. Of course, it is in the form of x raised to n, but x is not a single function here. It is 2x plus 3. Similarly, 1 upon 2x plus 3 whole raised to 3. Here also, this is not a single function. So we can compare this with 1 upon x raised to n. But here, this denominator, instead of x, it is 2x plus 3. It is not a single function. Sine of cos x. If it is sin x, we can write the derivative directly as cos x. But here it is sine of cos x. Next is sec of tan of root x. If it is sec x, we know the derivative of sec x is sec x into tan x. But here it is sec of tan of root x. Next, sine of x square plus 5. If it is sin x, again we can write derivative as cos x. But instead of x, it is x square plus 5. Next is cos of root x. If it is cos x, we can write the derivative as minus sin x. But here it is cos of root x. Root of sine of root x. If it is only root of one function like x, we can write as 1 upon 2 root x. But here it is root of sine of root x. We don't know, it is not in standard form. Root of x square plus 5. If it is only x square plus 5, we can write the derivative. So if you see all these functions here, none of the function fit in our standard forms. That is the 20 standard forms what I have given you. So any function which doesn't fit in the standard form, then straight away, or if you are unable to use the standard form when the function are given in this form, then we can say these are nothing but composite functions. So these types of functions, we call them as composite functions. So very simple to understand. If you are unable to apply 20 standard forms or none of the function given, if it doesn't fit in your standard forms, then it can be considered as composite function. Now, how to differentiate composite function? These all functions I will differentiate one by one. Before going to that, first we will see how to differentiate composite function. Composite functions can be differentiated in two ways. One is by substitution. Using what is called chain rule. By substitution using chain rule. Second method is direct method. You should know there are two methods. One is using chain rule by substitution. Second is direct method. So I will just show you one example for what is this substitution method. Nowhere we are using method of substitution. All sums will be differentiating by direct method. So first we will go for substitution using chain rule. So with the help of example, I will define how to differentiate by substitution using chain rule. Then with the help of that, we can also define what is composite function. So I will take a simple example. Y equals to sine 2x. I will take simple example, y equals to sine 2x. Now, the moment we see, we can make out instead of 2x, if it is x. Instead of 2x, if it is x, then it will be sine x. Or instead of 2x, if it is some function t, then derivative of sine t will be cos t. Comparison to sine x is cos x. So we want to remove this 2x. So we have to go for substitution, that is put 2x is equal to t. To go for substitution, put 2x is equal to t. When you put 2x is equal to t, what happens to given function? Given function becomes y is equal to sin t. So I've gone for the substitution. 2x is equal to t, then this becomes y is equal to sin of 2x becomes sin t. Then I will write a formula here. That is, your dy by dx will be, first you have to differentiate y with respect to t, or we can take, generally we are using u. So in integration we are using t. So I will take first 2x is equal to u. Then y will be sin u. I will take 2x is equal to u, y will be sin u. So I will write again here. I am put 2x is equal to u. So y equals to sin u. Even you can take t, but the common notations we will be using is u. Even in textbook they are using u, so we will use u. So I will write put 2x is equal to u, then this becomes y is equal to sin u. Then what about dy by dx? So first differentiation will be y with respect to u. So when you differentiate y with respect to x, it is dy by dx. When you differentiate y with respect to u, it will be dy by du. So I will write here dy by dx is dy by du, then u with respect to x. So u with respect to x will be du by dx. So the new formula will be dy by dx is equal to dy by du into du by dx. So you have to put into here. Then this particular formula is called chain rule, and this is a formula for two substitution. So here we can go on increasing the number of substitutions. Accordingly, the formula will go on changing. So this is a simple formula. Dy by dx is equal to dy by du into du by dx. So what will be dy by dx then? Then dy by dx will be, so dy by du is d by du of y. So I'll write here d by du of y. What is y here? Y is sin u. So I'll substitute for y. So d by du of sin y, this into will be as it is. Then du by dx will be d by dx of u. What is u? U is 2x. So this is called formula for chain rule, or this is a formula which we call it a chain rule. So dy by dx is dy by du into du by dx. Then using this formula I will write dy by dx is equal to dy by du is d by du of y. Y is, from this we can write sin u. And du by dx is d by dx of u. From this we can write u is equal to 2x. So what will be dy by dx then? Dy by dx will be, derivative of sin x is cos x. So sin u will be cos u into derivative of 2x. 2x is like c into u. So c into u is, now we should go on using the algebraic forms and standard forms orally. So derivative of 2x is 2 into derivative of x. So 2 is constant, derivative of x is 1 using standard form. So it is cos u into 2 into 1. So we can rewrite this as, first number 2 into 1 is 2, then 2 cos u. So this is 2 times cos of u is 2x. What is u here? 2x. 2 times cos of 2x. So what is derivative of sin 2x? Derivative of sin 2x is cos 2x into 2, or 2 times cos 2x. This is how we differentiate using what is called chain rule. So this is a method, already it is there. There are two methods. One is using substitution by the formula chain rule. Second is direct method. So you just learn there is a method that is called chain rule. This way if you go on substituting, the given function reduces to standard form, then we can go on differentiating. Now we will come to the main topic or the main format, direct method. Second method is direct method. So one by one, whatever examples I have written, those all examples I will go on differentiating one by one. So first one I will go for sin 2x. Now to differentiate this, I will give few steps. You have to remember those steps. So what are those steps? First step is, if it is composite function, so your first step will be compare with x raised to n or 1 upon x raised to n or root x. Your given sum will be either in one of the three forms. Either it will be in the form of x raised to n or 1 upon x raised to n or root x. I will show you with example how it will be compared with these three forms. And write a derivative. This is your first step. The moment any function is given, you have to compare with x raised to n or 1 upon x raised to n or root x, then write the derivative. So if it is not comparable with these three, then you can go for directly second step. What is your second step? Go on writing. What is your second step? Second step is go on writing derivatives of individual function. Go on writing derivatives of individual functions one by one from LHS to RHS. These types of steps you cannot find. Don't search in textbook, you will not find. Only for easy follow and easy to make the differentiation, I have made these two steps. So your first step will be compare with x raised to n or 1 upon x raised to n or root x and write the derivative. Then second is go on writing derivative of individual functions one by one from LHS to RHS. What do you mean by individual functions? I will tell you here. So for example, meaning of individual functions. So sine of cos x. So you cannot, there is no power here. So there is no power means you cannot compare with x raised to n or 1 upon x raised to n or root x. So sine of cos x. Then second step is go on writing derivative of individual functions one by one from LHS to RHS. So you have to start from here. What is your first function? Sine. So I will write here, given function is y equals to sine of cos x. Your first function is sine. So go on writing derivative of individual function one by one from LHS to RHS. So which are the individual function here? First one is sine function, second one is cos function. So what is derivative of sine? So derivative of sine is cos. So I will write here dy by dx. First function is sine. I will write as cos. Derivative of sine is cos. But instead of x it is cos x. You cannot change this function. This you have to keep as it is because your first function is sine. So it will be sine of cos x. I'll write here, cos of cos x. So derivative of first function is over. What is your next function? Next function is cos x. What is derivative of cos? Cos is minus sine x. So always you have to put into and write. So the first function is sine, derivative of sine is cos. So it becomes cos of cos x. Into next function is cos x derivative is minus sin x. If you want this to write neatly, again you can rewrite this as minus times cos of cos x into sin x. Don't combine any functions here. Now suppose instead of two functions, if I take one more example, sine of cos of root x. Now there will be three functions here. There is no power. First function is sine, second function is cos, third function is root x. So first you have to write derivative of sine. What is derivative of sine? Derivative of sine is cos. So I will write first cos. Remaining whole function, when you write First function, this whole thing you have to consider orally as x. Then what is derivative of sin x? Cos x. So this will be cos of root x. So first function is over. Next we come to second function. What is your second function? Cos. So when you consider second function, this root x you have to consider as x only orally. So cos derivative is minus sin. So write into minus sin of root x. First function is sin, derivative of sin is cos, this whole thing as x, so it is cos of cos root x. Next function is cos, so into again minus sin of root x. Your third function is root x now. What is derivative of root x? Derivative of root x is 1 by 2 root x. So written here, derivative of all individual functions 1 by 1 from LHS to RHS. First sign is cos, then cos is minus sin, then root x is 1 by 2 root x. Again you can write neatly as minus cos of root x into sin of root x whole divided by 2 root x. So next video I will show you some more sums in detail. I will differentiate more sums in the next video. So make yourself the concepts clear.